Hello everyone, this is mathematics lesson for grade 8. This program is organized by Addis Ababa City Administration Education Bureau in collaboration with Addis Media Network. I'm teacher Mamu. I will teach you grade 8 mathematics. Well, today we will have a discussion on Euclid's theorem, okay, one of the theorem on right angled triangle. But before we proceed to the present lesson, I will remind you some of the things that we have seen in our previous lesson. Okay, in our previous lesson, we have seen the exterior angle theorem, which says the sum of the two remote interior angles is equal to the exterior angles. Geometrically, if we have a triangle like this, okay, having two remote interior angles x and y, okay, assume these two are our two remote interior angles. The sum of these two gives us the exterior angle z, right? So z is x plus y, okay? We have seen this theorem and we have seen the proof of this theorem, okay? To prove this theorem, we apply two different things. One of the thing is the concept of sum of interior angles of a triangle. The other one is the sum of a straight angle is 180 degree. Roughly speaking, if you take this as W, clearly x plus y plus w is 180 degree based on the sum of the interior angle theorem, right? The sum of any triangle, the sum of the angle of any triangle is 180 degree. From this, you can have this equation. The other thing, W and Z together forms a straight angle. So any straight angle is 180 degree, right? So from these two, we can see that by comparison, okay, by comparing these two expressions on the left side, you can see that z is x plus y, right? So this is how we proved the theorem 5.2, which deals about the exterior angle theorem, right? And based on this theorem, I asked you a certain question to practice it. Hopefully you did those questions. Good. So today we will see the Euclid's theorem, which is 5.3. Okay, theorem 5.3 is about Euclid's theorem. Okay. Euclid is the name of a person. This person is a mathematician who lived 365 years before the birth of Christ. And this person is believed to be the father of geometry. Okay, today we will see his theorem and how it can be proved, right? And Euclid's theorem states that in a right-angled triangle with an altitude to the hypotenuse, the square of the length of each shorter leg is equal to the product of the hypotenuse and the adjacent segment into which the altitude divides the hypotenuse, right? So this theorem says in a right-angled triangle, triangle with an altitude to the hypotenuse, okay, there should be a right angled triangle with an altitude to the hypotenuse. The square of the length of each shorter leg is equal to is equal to the product of the hypotenuse and the adjacent segment, into which the altitude divides the hypotenuse. Okay, this theorem is a little bit lengthy. I will repeat what this Euclid theorem is stating. Okay, in a Euclid's theorem, first of all, we need to have a right-angled triangle with an altitude to the hypotenuse, right? I will tell you what the geometric interpretation of this theorem looks like. But here, this Euclid theorem says, in a right-angled triangle with an altitude to the hypotenuse, the square of the length of each shorter leg is the product of the hypotenuse and the adjacent segment into which the altitude divides the hypotenuse. Okay, don't worry, I will show you how this theorem looks like geometrically. Okay, so suppose we have a certain triangle. With vertices A, B, C, and this triangle should be a right-angled triangle. Say it forms 90 degrees at C. Okay, the first thing, this Euclid's theorem is applicable whenever you have a triangle with a right-angled triangle. Say at C we have right-angled triangle, and there should be an altitude drawn from 90 degrees to the hypotenuse. Okay, if you construct an altitude from C to some point on AB, say CD, okay, CD is the altitude. Now, this Euclid's theorem tells us the square of, okay, AB based on this triangle ABC, AB is the hypotenuse. So it should be the longest side, right? So geometrically, this Euclid's theorem is telling us the square of each leg is equal to the product of the hypotenuse and the adjacent segment into which the altitude divides the hypotenuse. That means AC square is equal to, this square is equals to AD times AB. AD times AB. Okay? The other leg is BC, and the square of BC is the product of the adjacent segment BD times the hypotenuse. Okay, these two are the equations that we obtain from this theorem, right? So these two should be satisfied in Euclid's theorem. Now I will show you how we can prove these two formulas, right? So to prove this formula, we need to apply the concept of similarity that we have discussed in the previous unit. Okay, now consider the bigger triangle, which is the right-angled triangle, the bigger triangle ABC. Okay, consider triangle ABC. Triangle ABC, you can find a similar triangle which is similar to ABC. ABC is similar to ACD. Okay, these two triangles are ACD. These two triangles are similar. Okay, we have seen different similarity theorems. Okay, how can we say these two triangles are similar? ABC and ACD are similar. How? If you see, these two triangles have some common angles, A. Okay, A is common in both these two triangles. The other thing, At C, triangle ABC forms 90 degree at C, and triangle ACD forms at D. So you can see that there are two congruent angles in these two. By default, their third angle will also be congruent. But we don't need the third. So from these two congruent angles, we can say that these two triangles are similar by the reason angle similarity, right? Okay, now if you have two similar triangles, do you remember what we can say about the ratio of their corresponding sides? Well, if two triangles are similar, the ratio of the pairs of corresponding sides are congruent. We have seen this thing in the previous unit. So by similarity, you can obtain AB, okay, this AB over AC, okay, over AC must be the same as BC. If you take BC, here you have to take CD. BC over CD, right? And lastly, AC, okay, AC over AD must be the same. AC over AD. Okay, all these ratios are proportional and they are constant, right? So by similarity of these two triangles, we can extract or obtain these ratios. Now, I need you to critically observe all these ratios. Okay, all these three are the same, so you can take this and this. Okay, take the first and the third ratio. Then from this you obtain AB over AC is equal to AC over AD, right? Now take a crisscross. Okay, you can crisscross it. So whenever you crisscross this result, AC times AC is the same as AB times AD, right? So this means AC times AC is AC the whole square. This is equal to AB times AD or AD times AB, okay? Multiplication is commutative, so you can write in any order, no problem. So this tells us AC square is equal to AD times AB, which is exactly the same as the first result, right? So if we have this kind of triangle, right angle triangle with an altitude drawn from 90 degrees to the hypotenuse, then definitely the square of each leg is equal to the product of the hypotenuse. Okay, AB is the hypotenuse in this case. The product of the hypotenuse and the adjacent side. Look, AD is adjacent to AC, right? If you are taking the squared value of AC, it should be the product of the adjacent side into which the altitude divides the hypotenuse times the hypotenuse. Okay, it's very easy to remember this formula. In both cases, you have the hypotenuse, AB, right? Here, BC square is the same as BD times AB. We can obtain the second formula by taking another similar triangle. Okay, here you can make like this. To prove the second formula, again, you need to take another similar triangle, ABC. Again, you can consider triangle ABC, the bigger right angle triangle. Take this bigger triangle, and we have already taken this ACD. Okay, now let's change another triangle. Okay, let's find another similar triangle which is similar to ABC. Now, if you take CBD, okay, triangle ABC is definitely similar to triangle CBD. How? These two triangles have 90 degree at C and D. Okay, they have 90 degree at C and D, right? The other thing, their middle angle, B, here we have B, they have another common angles, right? So from this figure, we can observe that these two triangles have two congruent angles. So if you have two congruent angles, by default, the two triangles are similar. Okay, you don't need to mention the detailed proof. You need to state by angle similarity. Or already we have seen what the different similarity theorems looks like in the fourth unit. Now, this is the first thing that you need to extract from this triangle, right? So by similarity of these two triangles, we can take the ratio of the pairs of corresponding sides as congruent, right? Because if two triangles are similar, the ratio of the pairs of corresponding sides are congruent. So this tells us AB over CB must be the same as BC over BD. And this must be the same as AC over CD, right? AC over CD, okay? You can get this ratio by similarity of the two triangles, right? So now from this, you can take the first two ratios, okay? If you take BC here, you need to take BD. Good. So if you compare the first two ratios, and take a crisscross, you will get BC times CB. BC and CB are the same, right? They are the same. Whether you call it BC or CB, we are talking about the same segment, right? There is no problem in that case. So the product of BC and BC is BC square. This is the same as AB times BD or BD times AB, okay? So BD times AB, okay? So this result tells us the square of one of, or the other leg, the square of the other leg is the product of the adjacent segment and the hypotenuse, right? As you can see here, BC is the product, BC square is the product of BD times AB, which is exactly the same as what we have already mentioned at the beginning, right? This way you can prove Euclid's theorem. By the way, you may forget the proof of Euclid's theorem, that's okay. But you should remember the formula that we use in triangles that requires Euclid's theorem, right? So that is a must. In our calculation, we need to apply the formulas, right? So let's see some examples that requires the concept of Euclid's theorem, right? The first example, let's see the first example. Given a certain triangle, with 90 degree at some point here, say A, B, C, with an altitude drawn from C to some point D, given in the figure below, given AD is 4 centimeter and BD is 9 centimeter. Okay, assume this is 4 centimeter and this is 9 centimeter. Then find the unknown sides AC and BC. Okay, clearly, if you see this figure, the bigger triangle ABC is right angle triangle, and we have an altitude drawn from 90 degree to the hypotenuse. Okay, say this is an altitude drawn from 90 degree to the hypotenuse. So whenever you see this picture, we can sense that we can apply the concept of Euclid's theorem, because Euclid's theorem says in a right-angled triangle with an altitude drawn from the 90 degree to the hypotenuse, the square of each leg, the square of the length of each leg is equal to the product of the hypotenuse and the adjacent side into which the altitude divides the hypotenuse, right? So if you know that theorem, at least if you know the formula that Euclid's theorem is saying, you can easily find the unknown variables AC and BD, right? So here, since this triangle satisfies the statement in Euclid's theorem, you can take the squared value of one of the leg, AC square, is equal to the product of the adjacent side, AD, times the hypotenuse, AB. Okay, this is one of the formula that we have already proved, right? The second formula is the squared value of the other leg, BC square. BC square is equal to the adjacent segment, BD times the hypotenuse, AB. Good. So you need to have these two formulas to find the unknown sides in this triangle. Look, clearly the hypotenuse, the length of the hypotenuse in this triangle is known, right? The whole this segment is the sum of these two, 4 plus 9, which is 13, right? So we don't have any other option to calculate the unknown sides AC and BC except applying the Euclid's theorem, right? So based on the theorem that we have already proved, the squared value of AC is equal to AD times AB. So now let's calculate AC. AC square is equal to AD, which is 4 centimeter, times AB, the sum of the two parts makes or gives you AB, which is 13 centimeter, right? So now this can be expressed as 4 times 13 is 52 centimeter square, because centimeter by centimeter is centimeter square. So AC square is equal to 52 centimeter square. Okay, now you can take both sides in the radical, then AC becomes square root of 52 centimeter square. Okay, this centimeter square can be taken out from the radical, it becomes centimeter. So this is radical 52 centimeter. Okay, in your answer you may not directly obtain radical 52 because there are different ways to write a certain number. Radical 52 can be written in a different ways. One of the way can be radical 52 can be written as 4 times 13. 4 can be taken out from the radical, so that in the radical 13 will remain, then this becomes 2 root 13. Okay, you need to be familiar with different ways of writing a certain number. So it's okay if you put AC is radical 52 centimeter, or AC is 2 root 13 centimeter. Okay, both these two are the same. Okay, they are equivalent, and the value of AC is radical 52 centimeter or 2 root 13 centimeter, right? Now let's calculate the second unknown side, BC, right? So when we come to BC square, we have BD times AB. Okay, BC square is equal to BD is 9 centimeter, and AB is the whole this part is the sum of AD plus DB, which is 13 centimeter. Okay, so 9 times 13, you can multiply it. If you don't have calculator, no need to directly multiply. You can put as it is and take out a perfect numbers from the radical, right? So BC is equal to, in the radical, 9 times 13 centimeter square. Now centimeter square can be taken out as centimeter because this radical can avoid the square part, and 9 also can be directly taken out from the radical. Square root of 9 is 3. So without the need to calculate these two numbers, you can write BC is equal to 3 times in the radical 13 centimeter. Okay, this way you can calculate the unknown sides of a triangle with the only information, the hypotenuse. Okay, by having only the hypotenuse, if you have a certain altitude drawn from the right angle triangle, you can calculate the unknown two sides, right? So this is the first example. Let's see the other example. Okay, in the figure below, find the value of x, y, and z. Okay. Okay, in the second example, you are asked to find the value of x, y, and z where the triangle is a triangle of the form like this. Okay, assume this is a right angle triangle, here 90 degree, and say this is the altitude drawn from the 90 degree to the hypotenuse. Because if you consider the bigger triangle, it's a right angle triangle, definitely, because we have 90 degree. And we need to have one more thing, which is altitude drawn from 90 degree to the hypotenuse, so that we can apply the concept of Euclid's theorem, right? So assume this is x, y, and z. Let's say the adjacent sides are 9 centimeter and 16 centimeter, right? So from this figure, based on this figure, you are asked to find the unknown variables x, y, z, right? So I will give you 2 minutes to find these unknown variables x, y, and z. Don't forget to apply the theorem, the Euclid's theorem, which says the squared value of each leg is the product of the hypotenuse and the adjacent side into which the altitude divides the hypotenuse, right? So take 2 minutes to find these unknown variables x, y, and z, then we will do it together. Well, I hope you tried to find the unknown variables x, y, and z. Now let's see how these unknown variables can be calculated and what it looks like, right? So to apply the Euclid's theorem, you need to observe that the triangle is a right angle triangle. And one more thing, you need to have an altitude drawn from 90 degrees to the hypotenuse. Clearly, these things are observable on this picture, okay? So you can apply the concept of Euclid's theorem. So let's see how it looks like. So let's give a naming for each vertex, say A, B, C. So clearly AC will be the hypotenuse. To apply the formula for Euclid's theorem, you need to know which side is the shorter leg. Okay, AB and BC are the shorter legs, and the longest leg is AC. So based on Euclid's formula, BC square is, this square is the product of the adjacent side, called, this is D. Okay, you can give name for each vertex. If not, you can jump it. Okay, that is up to you. So this square or Z square is the product of CD times AC based on this thing, right? So BC square is equal to CD times AB. Okay, so this means Z square is equal to 9 centimeter times AB is the whole, it's not AB here, make it C, okay? Because the hypotenuse in this case is AC. So I need you to correct in this way. Make it AC. So CD is 9 centimeter and AC or CA is the sum of these two segments. So whenever you add 16 centimeter and 9 centimeter, it gives you 25 centimeter. So in place of AC, you can substitute 25 centimeter. Okay, so Z square is the product of these two. You may have a calculator. If not, no problem. You can directly put this thing in the radical. So Z becomes in the radical 9 times 25 centimeter square. Now everything from this radical can be taken out, right? Square root of 9 is 3 and the square root of 25 is 5. Okay, if you want, you can also multiply 9 and 25. The product of 9 and 25 is 225. Okay, square root of 225 is 15. Okay, 225 is a perfect square and it can be taken out from the radical. But to avoid that calculation and to obtain the result quickly, it's also good to avoid that multiplication. It saves your time. Now Z becomes 3 times 5. This centimeter square can be taken out from the radical as centimeter. So now it's very simple calculation. The product of 3 and 5 is 15. So Z value here is 15 centimeter. Okay, we have one of the unknown variable Z. Look, we have only two legs, AB and BC in this figure, right? So you can also apply Euclid's theorem to find the value of x here, right? So to find this x value, you need to use the formula, the squared value of this leg, AB square is equal to the product of the adjacent side, AD times the hypotenuse, AC, right? Okay, depending on the variables that you name each vertex, the formula may depend on the variable that you are taking. But you need to stress that the squared value of this leg is the product of the adjacent side and the hypotenuse. Okay, you need to keep this thing, not the variables. Okay, don't try to memorize the variables. Okay, you need to think that way. Now, AB square means AB is x, so x square is equal to AD is 16 centimeter, 16 centimeter, times AC is the sum of these two segments, which is 25 centimeter. Okay, so taking both sides by radical, x becomes a square root of 16 times 25 times centimeter square. Now I don't have calculator to exactly know this thing. Sometimes in your exam, calculator may not be allowed. So in this case, you need to be very systematic, right? You don't need to multiply 16 times 25, okay? So in this case, you can directly take out numbers that can be taken out from the radical. So clearly 16 and 25 are both perfect squares. So we can take out these two numbers from the radical. So x becomes 4 times 5, because the square root of 16 is 4, square root of 25 is 5. Then the centimeter square can be taken out as centimeter. Now it's a very simple calculation. Finding the product of 4 and 5 is very simple. So x becomes 20 centimeter. Now we have the second unknown variable. Okay, we have already said we have x value, which is 20 centimeter. The only thing that is left here is calculating y value. Here, to calculate this y value, you may not directly apply Euclid's theorem, but you need to be systematic here. Either you take this triangle, this right triangle, or this right triangle, right? Both way you will get the same answer. If you are taking this triangle, okay, consider only triangle BDC. Triangle BDC is a right angle triangle, okay, and for triangle BDC, BC is the longest side, okay? So you can apply Pythagoras theorem or some other things which is not directly related with the present lesson. But to get or to obtain the value of y, you can consider only triangle BDC and apply Pythagoras theorem. Okay, so this gives us y square plus 9 square is equal to z square, which is 15 square. Okay, the square of 9 is 81. 81 plus y square plus 81 is equals to 15 square, which is 225, right? Now you can take y square is equal to 225 minus 81, and this difference is 144. Okay, y square is 144. Okay, so y becomes a square root of 144 or 12. Okay, so the value of y in this case is 12 centimeter. Okay, so don't worry about this case. Okay, we will have another discussion regarding Pythagoras theorem, which is going to be a discussion in the next period. For the time being, you can calculate this way, right? But from this discussion, I need you to understand how you can calculate this variable and this variable, okay? We will have more discussion on how we can find the variable on the middle case, right? So this is how it works. Okay, this is all about Euclid's theorem. So now I will give you one question that requires the concept of Euclid's theorem. So find the variables x and y in the figure below. Okay, our figure looks like a triangle with 90 degree at some point, okay, with an altitude drawn from the from 90 degree to the hypotenuse. You can call it A, B, C, D. Say this is X and this is Y, and say this is 10 centimeter, this is 12 centimeter, right? So to explain this triangle ABC, as you can see here, is a right angled triangle. That means AB will be the hypotenuse for the bigger triangle. And we have also an altitude drawn from 90 degree to the hypotenuse, right? So based on this information, I need you to calculate the value of X and Y, right? Don't forget to apply the formula that we derived before, okay? The formula that Euclid is stating, right? So based on Euclid's theorem, try to find the value of X and Y from this figure. So this is all for today. I hope you enjoyed the lesson. We have seen what Euclid's theorem is saying. We have seen how the Euclid formula is derived, right? And we have also seen examples that requires the concept of Euclid's theorem. So based on this, the examples that we have seen before, don't forget to calculate these X and Y values. This is all for today. Thank you for watching.